Hello, everyone. How are you guys doing today? Good, great, great. I'm okay. Not bad. Um, so tomorrow is what? Do you remember what you're going to do tomorrow? Exam. Did you study last night? Homework, great. I actually extended the homework, I believe. I did, right? Chapter 1 homework, I extended till chapter 2 homework. So if you haven't done homework, few things or something you are not able to complete by the deadline Monday midnight, then you still have time next Monday midnight. But I would suggest not to delay your homework because you don't have time. We already passed 1 week, and tomorrow we'll pass 2 weeks. So that means you have only 3 more weeks. The last week, no homework. Okay. The last week, Monday, is the last homework. And then you have Tuesday, Wednesday to review. And then Thursday, we're going to have our final exam. Okay. So no matter how much you beg me after Monday to open the homework, I'm not going to open the homework because there is no point of doing the homework if you fail the final exam. To pass this class, the first requirement is you have to pass the final exam. So you have to really study. And tomorrow, after tomorrow, you'll know how you're doing in this class. We're going to have only 2 exams. Will we be able to do something today? It depends on you. Do you have any question? Well, just we went over a lot, in the first 1 and 2 chapters. So yeah. Quick review of those. Quick review. Okay, let's see. We only had 4 classes and 5. Yeah. So I don't even know what to review because I told you everything that you needed to know. So what specifically you want me to go over? If you tell me like what you don't remember, I can go more. But if you tell me to review everything, that will not be a good idea. But let me scroll through the notes real quick. Okay, so chapter 1, we learned so many things. So first thing you should remember from all these things is the green one. Piecewise function. Okay. So from here, first thing you should know how to find the equation of parallel and perpendicular line. That means you have to know what's the slope for parallel lines and what's the slope for perpendicular lines. And then we have some calculator problem. Oh, don't forget to bring a calculator tomorrow, a scientific calculator. In the calculator part, you have linear application. So there are a few linear application I gave you here. Study those. You don't just memorize them, okay? Try to see the solving process because you are going to see a similar question, not the exact same question. So you need to know the method, solving method, not all the numbers. And then from here, you need to know, let's see, first green thing, x-intercept, how to find x-intercept, y-intercept. So how do you factor? How do you set each factor equals to 0? You need to know all these. You need to know for rational, how do you find vertical asymptote, horizontal asymptote, x-intercept, y-intercept, what else we learned? Domain. So for rational, you need to know 5 things. Also, definitely need to know how to find odd function and even function. So for even function, it doesn't matter what function they give you, you always have to find what is f of negative x. So you replace all the x with negative x, and then you compare that with the original one. If f of negative x is same as the original, then it's even. If it's not, then you go do more. What do? You change positive y to negative y. Basically, you change the sign for every term in your equation. And then you compare that with f of negative x. If f of negative x is same as your negative y, then they are odd. And if you have none of them, it's neither. So I'll give you a couple, at least 4 to 5 of these. Because in the final exam, they actually give you a bunch of questions and just ask you which of these are odd functions or which of these are even functions. So I'll give you a bunch and you're going to identify which of these are odd and which of these are even. There is a shortcut. In the shortcut, if you have all the even powers, the sum of the even powers is automatically even. If you have all the odd powers on the variable, then sum of all the odd function is odd. But if you have a constant, then you should check. Like for example, x squared plus 1. Check whether it's odd or even. Or x cubed minus 1. Check whether it's odd or even. So if you have a constant, you should check with negative x and negative y. And if you have only all even powers, then it's automatically even. If you have all the odd powers, it's automatically odd. Okay. So if you use shortcut, then make sure you circle all the powers so I can see what method you used.
Mm-hmm. If the sum of the odd powers ends up being even, is it still?
No, I didn't mean that. I mean sum of odd functions. For example, x to the 5 plus x cubed. 5 is odd, cube is odd. So if you add to odd function, it's automatically odd. Not the power. Okay. I'm talking about the function itself. If you look at x to the 5, it's an odd function because it's 5 power. If you look at x cubed, it's an odd function because it's 3 power. So if you add to odd function, the result is supposed to be odd. But if you have odd and even combination, you should always check because sometimes they are neither, sometimes they are odd, sometimes they are even. So you have to check which one makes sense. For example, here we have cubic power is odd, square is even. So if you add them, you really have to check is this an odd function or even function? You cannot just guess it's odd or it's even. What else I have? For example, here we have 2x cubed. It's an odd function, but 8 doesn't have any variable. So you have to check if it's odd, even, or neither. Definitely it's not even, but is it odd or neither? You have to check. So when you have a constant, you should check. And when you have only odd powers, it's automatically odd function. If you have only even powers, it's automatically even function. Mm-hmm. And then for domain, we need to know domain for this type of function. Broken pieces. Okay. So remember, domain, you look at the x values, range, you look at the y values. And then domain for this type of function. So every function I noted here, it definitely should know the domain. See all the green ones? Definitely, you should know how to find this domain. Every domain, there are only 2 conditions. If you have a rational, its denominator cannot be what? 0. And if you have a square root, what's the condition? Cannot be negative. So you have only 2 conditions. Apply this condition into whatever is given to you, and then you match them, you overlap them. For example, in the left one, there are 2 conditions. One is the denominator, one is the radical. So that means the denominator, the thing inside, cannot be negative. And here it's allowed to be 0 because we have a 1. So if it's 0, 1 minus 0 is 1. It doesn't have any problem. But on the other hand, you have 4 minus x squared. So 4 minus x squared cannot be 0 because it's denominator, and also it cannot be negative. So you have to see which number makes this square root positive. So you need the number line to test out. And then, for example, here on the left, you have a problem with the numerator, cannot be negative. You have a problem with the denominator, cannot be 0. So find domain separately and then overlap them to see where they overlap. So I went to my details, all these questions. If you forgot, you can watch the recording again. I posted all these recordings. Different quotient, definitely one question on different quotient. And then transformation. We have several types of transformation. So you need to know, for example, here, if a function is given, and then these are the transformation given, you have to find which transformation is given in the equation. So it will be multiple choice. Same thing like this one. From the original graph, what's the transformation of the given one? Like this one. So remember, if it goes up, it's in exponential, and if it's if it goes fast, it's exponential, and if it goes slowly, since going slowly, then it's log. This is the log shape, and this is the exponential shape. Exponential graph, it goes really fast. The log graph, it's increasing slowly, little by little, little by little. So this is log, and this is exponential. You have to remember the shape. And then we have also, see, all of these are green. That means you must know all of this. And then for composite, you have to know composite. How do you find composite function? How do you evaluate composite function? See, the green mark means important. All the green examples are important. So for composite, there are several scenarios. Either you are given two functions, or one function, one graph, or you are given two graphs. One of the scenarios definitely will be in the exam. Decomposition, I'll think about it if I have space. Personally, I like decomposition, but it never came in the final exam. Inverse function, definitely find one inverse function. And then what else we have here? See, all of these are green example, B, C. A is too simple. So a question like B, C will be in the exam. And then piecewise function. Okay, so for piecewise function, you will be given several pieces into one graph or into one equation, and then you're going to find them based on the domain. So if you're given a graph, you look at the graph and see where those numbers are given. For example, f(0). When x is 0, you're looking at the y value. So I have y value here 3, so f(0) is 3. The f(1) is here. For 1, there are two y values. One is here empty circle, and one is at 5 closed circle. So empty circle means there is no y value. So you cannot take that. You have to take the closed one, 5. So f(1) is 5. And then f(4). So 4 is here, our y value is 0. So f(4) is 0. And most of the time in the final exam, they actually ask in this format. So once you find each one of them individually, just add or subtract depending on the sign. Now, if you are not given the graph or given the equation, you do the same thing. You just look at the domain. For example, here, it says find f of -2. Which domain has -2? Which function has -2? The top one. How do you know? Because it says for all the x equals to 1 or less than 1. So if you want, you can actually draw a number line to make your life easier. In this case, it will be easier for you to see which domain is for which function. So let me get the page here. We have two breaking points. One is -1 and one is 3. Now, this one is saying for all the x value equals to 1 or less than 1, our function is x³ - 1. The next one says for everything smaller than 1, bigger than 1, smaller than 3. So bigger than 1, smaller than 3, but 3 is included because we have the equal sign. 3 is included, so from here to here, our function is 2x + 1. And lastly, everything bigger than 3, excluding 3, for this part, our function is 1 - x². So if you put them on the number line, then it will be easier for you to identify where each point, which function has which one. For example, the first one is -2. -2 is here. That means you're using this function, -2³ - 1. And you find how much is this. The next one says find f of 0. Probably in the exam, they will not be in order. They will mismatch the position, but you have to identify which number belongs to which one. So f of 0, we can see clearly 0 is somewhere here. So you're going to use this function, 2 times 0 plus 1. And then the last one is f of 5. So 5 is here. That means you're going to use 1 minus 5 squared, this function. So whatever y value you get, depending on the sign, you add or subtract. Okay. So these are from chapter 1. Now let me go to chapter 2. Chapter 2, 2. Get out from here. Come on. And I posted chapter 3 notes on Brightspace just now. Okay, in chapter 2, you need to know how to find vertex from general form, standard form. Let's see the green ones. What do you have for green? Green. Okay, find x-intercept. So there are many types of functions. You need to know all of them, how to find x-intercept from all these type of functions. Y-intercept. For rational, I told you domain, x-intercept, y-intercept, vertical asymptote, horizontal asymptote. 5 things for domain, 5 things for rational. This is not green, not green. This one is green. So this type of question, one point is given, vertex is given, find the vertex form of the quadratic. And then, come on. This is also same. Y-intercept means they give you 1 point. Y-intercept means x0 and y is the number. So this one and the last one are the same. You plug in everything to solve for A. Once you have your A, you substitute A, H, and K into the function, and that's your vertex format. Application of quadratic. Definitely need to know. Anytime you see maximum or minimum, it's automatically vertex. Now, what point in the vertex except the y? Read carefully. If they ask for this variable, they're looking for x value. But if they ask for that time or anything, that means they're looking for the y value. So whatever they ask you, you definitely have to find that value first. And then substitute that x value into the function to get the y value. And you need calculator for this. See maximum profit, maximum minimum, automatically means vertex. And then for polynomial, you have to remember your end behavior, turning point, all this information, because you're going to identify equation with graphs. For example, this type of question. The equation is given, identify which graph. Or the graphs will be given, you have to identify which equation. Something like this one. See, all this green, remember to study all of those questions. Don't just memorize them, learn how to solve them. Because I'm not going to give you the exact same question, obviously. Similar. What is this topic? Oh, graphing. You don't have to graph, but you have to identify all of these things. And for rational, I told you. Domain, x-intercept, y-intercept, vertical asymptote, horizontal asymptote. 5 things. And for graph, maybe I can put the graph as an extra credit because graphing is not a fun part, right? Probably it will be extra credit. And then what else we have? This type of question. Some information will be given. You have to identify what they're asking for. And definitely one inequality. And with the inequality, I think chapter 2 is done. Yep. So definitely one inequality. And then your rational with 5 information. And then whatever I said, study all this. Any question? Okay. Well, we started chapter 3 yesterday. It will not be in the exam, not in this exam. It will be in the next exam and also in the final exam. So what we did yesterday was we started exponential function. And we said the formula of the exponential function is a leading coefficient A times some type of base B to the power X. Now there's a condition for B. B cannot be 1, no, B cannot be 0, cannot be 1, and it has to be a positive number. If it's a negative number, then it's a reflection. It can be negative, but it becomes a reflection. And then if that B is a whole number, sorry, not a whole number. If that B is bigger than 1, then you have an increasing exponential function. But if B is a fraction between 0 to 1, then it's a decreasing exponential function. And every exponential function without any transformation has a y-intercept 1. And the domain is from everything, negative infinity to positive infinity. It's the domain. And for range, it's the horizontal asymptote till the infinity, or horizontal asymptote till negative infinity based on your transformation. And then we have a horizontal asymptote. Horizontal means it's y equals a number. We get this number from up-down shifting. So if you don't have up-down shifting, that means it's y equals 0. For example, if we have only y equals 2 to the x, the horizontal asymptote is y equals 0 because there is no up-down here. However, if you have, let's say, plus 1, that means you have a horizontal asymptote y equals 1. If you have a minus 1 here, then it will be y equals minus 1. So that up down tells you your horizontal asymptote. And then we have reflection 2 types. If you have the negative in front, then it's x-axis reflection. If the negative is on the power, then it's a y-axis reflection because it becomes a fraction. And then the function plus a number means up, minus a number means down. If you have a number on the power next to the x, it means left, right, opposite direction. So x plus 1 means it's going 1 unit to the left. X minus 1 on the power means it's going 1 unit right. And then there are a few transformation we did. So the last thing we did was matching equation weight transformation. And now today we're going to do some fun things. Solving exponential. There are several types of exponential functions. I think at least 5 types. Depending on your type, you take different action. But our goal here is to use one characteristic of exponential. If we have same base on both sides of the equal sign, exact same base without anything extra added or subtracted, we can cancel the bases and we can set the powers equal to one another. That's one characteristic of exponential. Or anything has a power, as long as you have the same base anything, without anything extra, and then we can cancel them, set them equal to one another. Now, in exponential, that is our main characteristic. Our goal is to have the same base so that you can cancel them. Now, scenario number 1, the same base is given to you already. If it's already given to you, the life is easy. All you have to do is cancel the bases because they are same, and then set the powers equal to one another, and then solve for x. So, for example, if you subtract 3x, we get negative x equals 2. Then what is x? Negative 2. That's it. Same base is already given. Then cancel both bases, set the power equal to one another, solve for x. But if you don't have same base, your goal is to see, can you make them same anyhow? If you can, then you start from there. If you cannot, there is no way you can make them same, then we invite the opposite of exponential. It's called log. So either we use log, L-O-G log, or we use natural log, which is ln. So just like square root has opposite square, ln or log is the opposite of exponential function. So if you want to get rid of the exponential function, you invite log. If you want to get rid of the log, you invite exponential function. They're opposite of one another. But we do that when there is no way we can make the two bases same. So there are two solving methods. Make the bases same so that you cancel. If there is no way you can, if it cannot, there is no way you can make them same, then invite the log. So this one is easy, already given to us, the same base, so our life is simple. Now there is a second scenario. We have two different bases. However, we can change one base into other base. We can convert the bigger base into the smaller base. Great. So our smaller base is 2, we keep it. And our bigger base is 16. We have to change 16 in terms of 2. We know 16 is 2 to the 4. And then we have 3x minus 1. And then we use exponential, not exponential, the exponent rules. One of the exponent rules. When you have two powers together or multiple powers together, how do you combine them? Do you add, subtract, multiply, divide? Multiply. So we have 2 here, and you multiply this, so you get 2 to the 12x minus 4. Because this is 4 times 3x minus 1. So rewrite the bigger base in terms of smaller base. Once you have the same base, cancel the two bases, and then set the power equals to one another. So right side is 12x minus 4. But what do you on the left side? 1. Great. This 2 has invisible 1. It's not 0. It's invisible 1 power. So the left side has 1. The right side we already know. And then we solve for x. So how do you solve for x? What is our step 1? Add 4. Great. So we have 12x equals 5. And then the last step is divide by 12, not x, only 12. So x is 5 over 12. You see, depending on the scenario, we use different methods. The first one we cancel right away. The second one, before canceling, we have to make the bases same. And one more, try this by yourself. And see, this is green. That means important for the final exam or in class exam. Let me take that. Rizia, Hector G, here, Marco, here, Joanna, here, Dayanara, and Gabriela M, here, Neva, here, Hector B, and Faria, here, Arif, here, Malvina, and Gabriela D, and Mia, and Diego, not here yet, Tristan, and Ramzat, and Rachel, and Julia, and Ritika, not here, Idalia, absent, Fabia, and Angelo, not here, Isabella, not here, Steven, Brian, Shihan, and Kimberly here. Okay, who is ready? Volunteer? Gabriela. Mm-hmm. Mm-hmm. 6x. Mm-hmm. 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 Or you can simply take out x. X equals 0 is already given to us. And x equals -1. Yep. Perfect. Any question from anyone? Go ahead. Equal to 1 when, for example, here. These two doesn't have any power, right? So when you cancel the bases, the power has to be equal to one another. So what power we have on 2? But on the right one, both powers are visible. So when you cancel the bases, the visible x squared plus 7x is on the left side, the visible 3 times 2x, 2 times 3x is on the other side. And then since they both have x's, bring everything to one side. Any question from anyone? Okay, the next one. They look completely different, right? But they actually have the same characteristic. What do you think the first step should be? Great. This 17 is extra, so kick it out. So we have 7 x squared plus x. And how much we get from 32 plus 17? 49. Now, does this look familiar? So go ahead, try the rest. Ready? Who is ready? Hector. So 7x squared plus x equals 7 squared. X squared plus x equals 2. X squared plus x minus 2 equals 0. X plus 2, x minus 1. X plus 2, 0. So x is negative 2. And then x minus 1 equals 0. So x is 1. Great. Do you guys have the same answer? Wonderful. Now, the third scenario. In this scenario, we have two different bases, and we cannot convert the smaller one into bigger one or the bigger one into smaller one. However, they both have some common factor. For example, we cannot write 8 with 4 some power. It's impossible. But 8 and 4, they both have what factor in common? 2. So we are going to use that common factor to rewrite them. 2 to the what power going to give us 8? 3. And 2 to the what power will give us 4? 2. So we rewrite each base using the common factor. And from there we work. Brian, would you like to help me with the rest? What should I write next? Minus 3. Minus 8. Plus 3 minus 8x minus 8x. So how much you get? Negative 5 over 4. Yep, the answer is correct. Are you guys enjoying all these equations? So far, they're fun, right? I love these because they're not hard. Okay. A challenging one. Try by yourself. It looks challenging, but actually it's fun. Let me remind you of one exponent rule. If you have 1 over x, this is same as x to the what power? -1. Great. So use that exponent rule, your life will be easy. And if you have 1 over x to the n, how do you rewrite this? X to the -n. Ready? Fabia, you're so quiet today. Would you like to help me with this one? So 9 to the what power? +1. How did you rewrite 27? 4 minus x. -2x plus 1. 12 minus 3x plus 2 plus 4x minus 12 x equals -10. I don't have the answer. Do you guys have the same thing? Great, wonderful. Any question? So if the first step is unclear, what we did is this. First, we rewrite 9 to the -2x minus 1. And negative means you're distributing, so it becomes -2x and +1. Any questions so far? Okay, now the fourth type. We have totally different numbers. There is no way we can convert the smaller one into bigger one or bigger one into smaller one. It's impossible. Do you remember what did I tell you when something is impossible? You cannot change. Which one do you, what do we invite? Love. So when you have two terms, two different bases, and we cannot rewrite, we use ln, means natural log, or log, means just normal log. So if you have the habit of using ln, then that will be easier, because anytime you have e to the power anything, you must invite ln, because ln and e, they are opposite of one another specifically. So instead of using log, let's use ln. It means natural log, ln. So we apply ln on the left, ln on the right. So ln is a function. What you're doing is you're putting the left side inside the function and the right side inside the function. So what happens is this. ln, we write ln of 7 to the power x minus 2 equals ln of 3. So you're not multiplying. We're applying them inside the ln machine. Great. So ln has a rule. Let me actually write you the rule. The rule says anytime you have ln and then anything to any power, the power always comes down as a coefficient. So it's power times ln of the base. If you took 1030, this rule you already should know. So here we invited ln because we want this x minus 2 as a coefficient, not as a power. So this x minus 2 comes down as a coefficient, and we get ln of 7 equals ln of 3. Now I'm going to get the x alone. Now x has two problems. One is minus 2 and one is times ln of 7. Which one we get rid of first? The times or the minus? Times. What is the opposite of times? Divide. So we divide by ln of 7 both sides. So we have x minus 2 equals ln of 3 divided by ln of 7. And then to get the epsilon, what do we do last? Plus 2. And then you go to a calculator. This is a calculator question. You punch this and then you get the answer. But you have to be very careful when you punch this. You have to be careful with your parentheses. How much you have? 3.562, 2.564. So if they ask you to round 2 decimal places, 2.56. If you round to 2 decimal places, usually they ask you to round 2 decimal places. Is this correct? Do you guys have a different number? It's normal to have a different number because I said you have to be careful. Different numbers, anybody? So you have to close the parentheses here, must. And then for division, you have to close the parentheses again here. That's a good idea, actually. So depending on your calculator mode, you have different types. For example, here, I cannot write as a fraction. So like you did, we can start with the fraction, just parentheses. And in this calculator, first I have to punch the number and then ln. So 3 ln. And then we divide 7 ln. We close the parentheses and we add 2. Okay, so you try one. Right. You always have to get the decimal because this will be the calculator part. So you need to use the calculator to find the decimal. So then the next one. And see, all of these are green, means they're important for that sum. Absurd. Would you like to help me with this one, please? What did you do first? ln, so ln of this equals ln of that, 3 to the 2x minus 2 and 2, and then you cannot do it yet because you have to bring down your power. So you have 2x minus 2 ln of 3 equals ln of 2, and then you divide it by what? ln of 3. ln of 3, ln of 3, they cancel out. You have 2x minus 2 equals ln of 2 over ln of 3. Added 2, added 2. So you have 2x equals this thing, and then no problem. So divide by 2, and this is your x. So who is the answer for x? 1.32. And what's the next digit? 315. Okay. Round to 2 decimal places. So x equals 1.315. This 5 make 1 into 2. So x equals 1.32. Wonderful. Thank you, guys. And now something that is exponential, but it's related to inverse function. We are given f of x is 5 to the 3x minus 1. It's an exponential function. But somehow they want us to find out inverse function at 3. F inverse of 3. It will be hard. It will take long. Plug in 3 for what? X? How do you get f of 1? It's f inverse of 3. That aren't you about the 1 at the top? Yeah. Yeah. But this is the x for inverse function. Without doing that, how can you do that easily? We're going to use ln, but not now.
Did you just put it 1 over negative 1 over 5? Make it the opposite.
Negative 1 over 5. 1 over 5.
Oh yeah, negative 1 over 5. Wait. 1 over 5.
Oh, they are not same. This negative and this negative are not same. This negative means inverse, and if you have this, it means the whole thing to the power negative 1. So they don't become a fraction.
No, I say, but the inverse is the negative.
No.
Oh yeah.
The inverse function, remember? You're thinking inverse as perpendicular.
Plug in the 3 where x is, and then just turn it right now.
But if they wanted to find, if they wanted to plug in x for 3, they would ask what is f of 3. They didn't ask f of 3. They told us f inverse of 3. I forgot to name. Faria. Right. Do you remember the relationship between f and its inverse?
Yeah.
F of x equals y means f inverse of y is the x. So whatever we have x value here, that actually the y value for the original function. You don't have to switch anything because remember, domain for f is range for inverse, right? And domain for inverse is the range for original function. So this x equals this 3, is it domain or range for the inverse? Domain. So if this is the domain for inverse, it should be the range, which is the y for the original function. That's it. The whole thing is a 3. All we have to do is put 3 here. 3 equals 5 to the power 2x minus 1. That's it. And now solve using whatever we learned so far. Exponential method. It looks so tricky, so hard, but actually the trick is there. Domain for f is the range for y, range for inverse. So domain for the inverse must be range for the y. Range means y, domain means x. Now you solve it. We get everything. We have our equation, exponential. That's it. Now solve it. If you plug in x, you get a number. But you're not looking for.
It's the same, but that's so 12 and 3 and 2 x.
Can't go for it. This is the thing as well.
No. Using the 12 the 3 2
And then switch at the end.
So it's the same.
How can you switch? If x is 3, then how can you switch?
Like 2 to the
You
2 times
switch
3
the x with the y that goes down with x. It's the same. Pointer. Let me digest. Say it again. Gabriela. No, I want to learn it. Maybe it's easier. Go ahead. You said switch this f of x. With what? So we have f of x equals 5 to the 2 times 3 minus 1. Okay. So this is y. This is y. And then what you're going to switch? Oh, I see, I see. I thought you were finding the entire thing here, and then you just switch somehow. Because this is x, this is number, right? So, okay, I see. So basically, yeah, you're doing the same thing with an extra step. Interesting. I didn't think about that. Plug in extra number and then switch the number with the variable.
Like how they do.
Mm-hmm. And in the normal we always switch x and y. We never switch numbers. I never thought about that. But good thinking. Wonderful. So do you have the answer yet? Anyone?
Now, after
Mhm. What do you have?
we'll end up with
ln of 3 equals, so 5 to the 2x minus 1. So it becomes 2x minus 1, ln of 5, ln of 3, and then ln of 5, ln of 5, add 1, divide by 2. Yep. So how much is that? Anyone? 0.884. Let me see if I have the answer. Great, you got it. It is 0.84. So I actually did all the step in one step. Okay, but you get the idea, right? Because we already did so many examples step by step. Now we can just do everything in one step. Okay, now our last step, I believe. We have a specific base e. For specific base e, you will have to use ln. If you use log, then you get different answer. Because e and ln, they're inverse of one another. So anytime you have e to the power ln, or e and ln next to one another, or ln to the power e, ln and e next to one another, all of these, what's the answer? They all are equal 1. So anytime you see e and ln next to one another without anything between them, they always cancel out, they become 1. But it doesn't happen with log. E and log, they are not enemies. E and ln, they are enemies. So they fight till death. Okay? That's how they disappear. So what do you think our first step is? You cannot do that until your exponential is alone. Add 3. You always have to have your exponential alone, invite ln. So you add 3, add 3. Now you have e to the 2x alone and 19 on the other side. So what do we do now? We do not add, we apply. Apply ln to both sides. So you see add e and ln, they don't have any number between them. So they cancel out. We have 2x equals ln of 19. We divide by 2. So x is ln of 19 divided by 2. How much is that? With ln, we cannot do that in head. 1.47. Do you guys have the same answer? Great. Okay, the last one, right? Yep. the last exponential equation. It's 3 times e to the x. It's one term. And then you're adding 4. It's equal 5.6. You just to get the x alone. It's very similar to the last one.
E to the
E to the e is not 1. Let's see, e to the e. Let me clear. E to the power e. Yeah, 15.15. Let me clear this out and do it again. Anytime E and ln they're next to one another, it doesn't matter what's the relationship, as long as they're next to one another without anything between them, they always cancel out. For example, sometimes you may see e to the power ln. Sometimes you may see e times ln. Sometimes you may see ln and e, so ln and basic e. So if you see any of these three formats, it's always one. Ready? Mia, what is our first step? Subtract 4, great. So we have 3 times e to the x equals 1.6. Great. Divide by 3. So we have e to the x equals 1.6 divided by 3. You can do the math later. 8/15 from here. Okay. You should actually round in the middle because then at the end you get rounding error. So keep your fraction in the middle until the end. Do not round anything to get the accurate answer. Okay, so if I ignore the result here, keep my fraction. For now, leave it as a fraction. And then get the x alone. What do you need? Apply ln to both sides. So e ln, they cancel out. And you have x equals ln of 1.6 divided by 3. 0.53. That's wrong. Negative 0.62, and then the next digit 8. So it will be negative 0.63. Mia, do you have the same answer? But how do you get 8/15? They give you 8/15? Interesting. 8/15. But in general, do not try reducing your fraction in the middle because at the end, they actually give you rounding error. So if you want to get most accurate result, keep everything until the last moment, until the last step.
It's 1.6 times 5.
8 divided by 15. The method I think I can see is they get rid of the point, so you multiply by 10 here. So you have 16 times 10. Both of them are divisible by 2, so 8, 5. So you get 8 over 15. A different version of that. With calculus, we're always thinking harder way. We are smarter. We think not harder way, easier way. Okay, now we learned 5 methods of solving exponential. Why do we care? Why did you learn them? That's the main point, right? That's the question we always have. Why are you learning that? Whatever you're learning, why? Well, good news, this is actually very helpful because we do use them in real life. Where? In the financial world. So the application of exponential, we mostly use them in banking and biology, like bacteria growth or something decaying, something growing. So that's one field we use exponential. And the other field is money. We all love money, right? So when you deal with money, especially in the banking system, we need this exponential function. So there are 2 types of functions you have to remember, which you're already familiar with because you took 1030. Does this look familiar, guys? 1030. So the first one is if you're investing some money and you're compounding with something. So if you compound m times in a year, then the first formula we use. And if you don't compound with a certain compounding time, instead you compound continuously, then we use the second formula. The first formula says A equals P times 1 plus R over M, whole thing divided by N times T. Here, A is the final amount we get back at the end in the future. P means principal you invest when you invest your money. M means how many times you're investing in a year. R means what's the interest rate bank wants to give you. And then T means how long you're planning to invest your money. The same thing if you don't compound at a certain amount of time, but you do it continuously, then you use the second formula, A equals P times E to the power RT. See the E, the last example we did E, the same E is that there. Now, P means principal again, A means the final amount, future amount, R is the interest rate per year, and T is how long you're investing your money. So yes, you do have to memorize this formula correctly. I have no idea why, but I just know like E is a special base. E is a base, just like number 2. E is 2.1 and something. So what is so special about E? Mathematician invented that. I don't know. So if you can memorize them correctly, then all those questions will be easier for you. And yep, in the final exam, definitely one of these questions will be in the final exam. Either they're going to ask for the interest rate, or they'll ask for the time, or they'll ask for the final amount, or they'll ask for the principal. They will give you one variable to solve for in 2 scenarios. In your class, I actually noticed usually they use the continuous compounding scenario. So you definitely have to remember the compound continuous function. People actually use the term part to remember P times E to the RT. So people call it part formula. P times E to the RT. part. Okay, so let's do an example. Suppose you need $20,000 in 10 years for some reason. And then you went to the bank. The bank said, oh, we will give you 4.2% interest per year. And he said, well, I want to compound continuously. So the question is, how much did you invest today to get $10,000, $20,000 in 10 years with a 4.2 interest and continuous compounding? So if you see, anytime you see the word compound continuously, which formula? The part formula. A equals P times ERT. People call it part. See, part of the piece, part of this, part of that, is like part. So, what is our interest rate? 4.2%, but we cannot apply percent. You have to convert into decimal. What decimal we get? We move it to 2 places to the left, so 0.042. For how long you have to wait? 10 years. And what is this 20,000? A, the future amount. And what you're solving for? P. Since you're solving for P, let's divide by e to the RT both sides. So we have our P alone. P equals A divided by e to the RT. We have future amount 20,000. E is the base. Interest rate is 0.042, and we have to wait for 10 years. So find out how much you need to do to invest. Nearest money, it's money, right? So nearest penny. Any money problem we face, you're solving for money, always round to 2 places. Because our money is into money at 2 places. So who is the answer? The principal. Say it louder. 13, 11. 13, 14. 0.94. Same thing. Great. So you need to have 13,000 today. This sucks, right? You have to wait 10 years just to grow 7,000. What type of life you have? Okay, the next one. You're looking for interest rate. What annual interest rate you need if you want to compound continuously for 5 years to double your money? Of course. Whatever money you have, you want to double that. And you're going to wait 5 years. And you're doing compound continuously. The question is, What should be the interest rate if you want to double your money in 5 years? Mhm, mhm. Or you can choose 1 and 2. They didn't tell us how much you have. They just want to double the amount. Whatever you have, it's definitely going to double in 5 years with how much interest rate? It's an interesting question, right? If you compound continuously, and whatever amount you have, $5, $10, 500, 10,000, 5,000, 10,000, whatever you have, you want to double it in 5 years. Then how much the interest rate should be? And see, all of these are green, means one of these definitely will be the final exam. And obviously in the in-class exam. Not in this exam, in exam 2. Ready? Okay. Mm-hmm. Oh, let me write the equation first. Which equation you used? A equals part. So A is 2 if the principal is 1. Mm-hmm. Time is 5. So basically 2 equals e to the 5r. And then apply ln to both sides. E and ln, they cancel out, right? Mm-hmm. Divide by 5, divide by 5, divide by 5. Mm-hmm. Mm-hmm. Do you know if you turn your phone this way, it becomes a scientific calculator? So you can use a scientific calculator. On the exam, you definitely need real scientific calculator, not the phone. So here's the answer, right? 9 point, oh, sorry, I did something wrong, right? Oh, this is 9 point what? Point 3? 0.13, and Fabia has 9.9 point? 9.21. Okay, let's see who is correct. Multiply by 100. But let's see, we have 2 ln, and we are dividing by 5. 13 point. So we have 13. What happened here? 1386. 1386. So it's not 9. And then you move your decimal to 2 places to the right. So it's 13 point. All of these, they have percent how many places? 1 places. So they'll ask for 1 decimal places. So 13 point what? $13.86. So it depends on the direction. If they ask for 2 decimal places, the answer is 13.86%. If they ask for 1 decimal place, it's 13.9%. Go ahead. Sure. Sure. 10 equals 5 e to the 5r. Divide by 5, divide by 5, you end up 2 equals e to the 5r, exactly like this one. That's why the amount doesn't matter. It doesn't matter what amount you invest today, definitely it will be double if you use 13.9% interest rate, basically 14%. But will the bank ever going to give you 14% interest rate? No way. They may take 14% from us, but they will never going to give us 14% interest rate. Okay, so now I have few more questions. Let me put them together so you can work on them for 10 minutes. No, before that. Okay. And if you want to see the answer, you can also check your answer. 3 questions, but the third one has 3 pieces. So enjoy doing them with your neighbors. And I'll be back.
Just taking everything. Like I brought the glasses to take the coverage up and like the borderline. I took comps, and I took comps. Oh, my, I'm like, oh, I can't recover it.
Well, yeah, you.
Yeah. I know. Oh, yeah. I like that. That's very fun.
I guess so.
The last one I didn't do.
Cheapest, go ahead. It's basically asking which compounding gives you more money. Annually, monthly, daily, and you can also try continuously. Which one will give you more money? What do you think? Which one going to give you more money? Do you compound less time, more time, or continuously? See, monthly or daily? And if I add one more, continuously, what do you think? How do you know?
Because more compounding periods, more money you have.
Great. That is actually true. The more time you compound, the more money you gain. Krista, help me with the first one, please. A equals part. And then what is given? Doing our A. 15,700. Doing our P. 5,000 e to the doing interest rate 0.035. That means you're looking for time. So what is our next step? Divide by. Your goal is to get the T alone, right? So you want to get rid of everything that has next to the T, that are next to the T. You divide by 5,000 first. Whatever you're multiplying, you need to get rid of that first. So 5,000 cancel out. 0, 0 cancel out. We have 157 divided by 50 equals e to the 0.035 t. And then what? Whom do you invite? What's the opposite of E? ln. It's L, not I. ln. So you apply ln to both sides. So E ln cancel out. You have this thing equals 0.035 t. And the last thing to get the t alone is what? By 0.035. So you punch this in the calculator, this thing, 32 point what? 7 years. Really? From 5,000 to get 15,000, you have to wait 32 years? Wow. It's better to earn money than what? You can earn so much money than waiting 32 years just to get $10,000 more. Okay, let's see. Rachel, the last one. I mean, not the last one, the next one. A equals P e to the RT. So what is given and what is missing? A is missing. So what is our P? 7,000 e to the interest rate. 0.035, and you're waiting for 8 years. So this is simple. Punch everything in the calculator, how much we get? 9261.9. Great. Any question from anyone? Now for the next one, you just have to write one equation and then change the number for compound. So when you're not compounding continuously, what's the formula? A equals what? R over N to the power NT. So what is given here? What is the 7,000? P. 1 plus. What is our interest rate? 0.035. And then N is depending on what you have. So for annually, how much is our N? 1. For monthly, how much is our N? 12. For daily, what is our N? 365. So whatever N you're looking for, that goes here and also here. And how long time you're waiting? 8 years. So you just plug this N on 2 places, punch everything in the calculator, they're going to give you the answer. I'm skipping this because in the exam, usually they never ask for this. They always ask for the continuous compounding. Okay, I'm skipping this. And now we are going to do the opposite of exponential, the inverse of exponential. It's log. Since you only took 1030, so you actually have most of the idea about log. Just to refresh your memory, a logarithmic function is the inverse of an exponential function. It used to find exponent to which a base must be raised to get a specific number. It's written as y equals, or f of x equals log with some base b, and there is a thing next to the x, next to the log, we call it argument. So whatever we have here, this is called base. Whatever we have next to the log, it's called argument here. And on the right side, we call it exponent. Oh, here is the more detailed version. Now, log and exponential, they are inverse of one another. So you can actually switch log to exponential exponential to log. Depending on what you need, we can switch the other version. So in order to switch from log to exponential, what I do is I work on a cycle. So we start from the base B. That base B gets the right side as an exponent, and instead that equals to the argument. So I think of this as a cycle. B gets the power on the right side of the equal sign, and instead that equals to the argument. Then this thing becomes exponential. Now, logarithmic and exponential and special logarithmic are interchangeable. You just have to switch them around. Log becomes exponential, exponential becomes log. So base B goes on the log, on the leg of the log as a base. The argument, the right side of the equal sign, goes next to the log, and the power is the equal sign, whatever you have after the equal sign. So you just switch them around, one version turn into another version. We don't have to use anything extra. You don't have to deduct anything or add anything. Let's do some example, fun example. Rewrite log base 5 of the argument square root of 5 equals 1/2 as an exponential. So remember the cycle. Your cycle starts from the base of the log. The 5 gets 1/2 as a power. 5 gets 1/2 as a power. And whatever we get, we set that equals to the argument. And this is true. Square root of 5 is same as 5 to the 1/2 power. Gabriela, would you like to try the next one? 1/27 equals to 3 to the negative 3 power. And it's true, right? Negative means 1/3 cubed. So 1/27 is 1/27. That's correct. Who would like to go the other version? So we have a log. We need something here, and something there. So what goes on the base of the log? 6, great. And then what is our argument? Square root of 6. I should change color. This is 6, this is square root of 6. And then what is our right side of the equal sign? 1/2. So you can check. 6 gets 1/2 as a power, and we set it equals to square root of 6. Yep, it's same. Marco, would you like to do the last one? Log something something equals something. Base 5. Where? As an argument or as the right side of the equal sign? Where? Argument 1/5. That means the right side is -1. So 5 gets -1 as a power, and we set that equals to 1/5. Yep. Okay, now a little bit information about log and exponential. Inverse means they are same graph, they're just their reflection about y equals x line. So the point xy in log turns into yx in the exponential. They switch position. The domain for the log is range for the exponential. The range for the log is the domain of the exponential. So the x and y, they switch their position. Exponential function takes a small number and produces a large number. For example, 2 to the power 3. 2 is our base, 3 is a small number, but when you put 3 inside the exponential 2, it suddenly turns into 8. Or 2 to the, let's say 5. 5 is a small number. So 2 to the 5 is suddenly turns into 32. Right? Yeah. So exponential function, it takes a small number but produces a big number. For example, 2 to the 10. I have no idea what it's 2 to the 10. It's a huge number. On the other hand, log does the opposite. It takes a big number but produces a small number. For example, log 10 is 1. If you put 10 money, you put $10 in the log machine, it will return you only $1. On the other hand, exponential money is what we want in our life. We put a small amount, it gives us a big amount. So they are kind of opposite of one another in every possible way. Their graph also looks opposite of one another. Exponential graph increases very fast. The log graph, it increases slowly, little by little, slowly. Every exponential graph has y-intercept 1. Every log graph has x-intercept 1. So y-intercept in the exponential becomes x-intercept in the log graph. Also, exponential has horizontal asymptote y equals 0. Log has vertical asymptote x equals 0. See, they all are completely opposite. Now for the graph, the bigger the base, the narrower it becomes. For example, this one, the first one, has log base 10. This is the shape. The next one is log base, I think the example is here. The better one is here. Log base 2 is this one. So it's a little bit far from the x-axis. Log base 3 is closer to the x-axis. Log base 10 is even more closer to the x-axis. Log base 200, see, it's even more closer to the x-axis. So the bigger the number, the bigger the base, it gets closer and closer and closer to the x-axis. Do you remember what happened to the exponential graph? The bigger the base, what happened to the graph? Did I mention that? It gets closer and closer to the y-axis. For example, maybe this is 2 to the x. The next one is 3 to the x. The next one probably 10 to the x. The next one will be probably 100 to the x. The bigger the base, it gets closer and closer to the y-axis. So log must be the opposite. The bigger the base, they get closer and closer to the x-axis. So they're completely opposite of one another. Also, remember for whole numbers or bigger than 1, it's increasing function, but when you become fractional, it becomes decreasing function. Same scenario is here. For whole number log, it's this one, increasing function, but for decimal, let me write this figure. This is log 0.2. For decimal between 0 to 1, for fraction between 0 to 1, the log becomes a decreasing function. But they still have their x-axis, x-intercept 1. This one is log base 2. And also, log has a very important thing to remember. Log 0 doesn't exist. Why? Because when x is 0, we have vertical asymptote. It cannot exist. Also, like negative doesn't exist. See, there is no graph in the negative part. So how can you put a negative number in the log machine? You can have a negative, it will be reflection. So without reflection, log cannot take 0 or anything. Log cannot take 0 without reflection. Log cannot take 0, log cannot take negative. Without transformation. With transformation is possible. Without transformation. For example, here. The normal log has x intercept here. Now, if you want to move a little bit to your right, a little bit to your left, then you're going to add 2 inside the parentheses next to the x. So this x intercept goes 2 units to the left. So with the transformation, yes, we can go anywhere. But without transformation, log cannot take 0, log cannot take negative number. In other words, the inside cannot be 0. So whatever makes the inside 0, you have to omit those from the domain. For example, here, x plus 2 is here. So when x plus 2 is 0, for which x value? Negative 2. That means you have an asymptote at negative 2. You cannot cross your asymptote. So your domain has to be everything bigger than negative 2. Because we cannot have a negative inside, and you cannot have asymptote. You cannot cross the asymptote. Now here, x minus 5 means you're moving your x intercept 5 units to the right, and then you have plus 2, which you're moving out. So this x intercept goes 1, 2, 3, 4, 5 unit right, and then 1, 2 unit up. So this graph has an asymptote where x equals to where? What makes the inside negative? What makes the inside 0? 5. So there's the asymptote at 5. That means your domain is to be everything from 5 and above 5. You cannot have 5 from 5 to infinity. Okay. So every log graph, there are particle asymptotes. Every exponential graph, there are variety of the particle asymptotes we get from the inside. Whatever makes the inside 0, that is our particle asymptotes. So our graph lies only one side of the particle asymptotes. Okay, so I actually covered everything. Transformation, blah, blah, blah. What do I have? Domain. So let's find domain. Remember, domain is from particle asymptote to whatever makes log positive. Now we have a graph, we have a function log, but natural log ln 12 minus 3x. We have no idea what's the shape. So we have a vertical asymptote at 12 minus 3x equals 0. So what should be our x? 4. You add 3x. So we get 12 equals 3x divided by 3. Our x is 4. So there is an asymptote at 4. And now you have to see which side of the asymptote is positive. So pick a number from x equals 4 is the asymptote, right? There's a line. So 1, 2, 3, 4. This is the line the graph cannot cross. Now the question is, what's the shape of this transformation? Let me rewrite this. ln negative 3x plus 12. So you have a negative inside the parentheses. If you have a negative inside your function, what type of transformation we have? What type of reflection we have? About x-axis or y-axis? X square is upward, right? Negative x square is? So if you have a negative sign in front of the function, what type of reflection? X-axis or y-axis? X-axis. That means if you have a function, if you have a negative inside the function, what type of reflection you're going to have? Y-axis. So you have a reflection. The normal graph is this. The reflection about y-axis must be that. Now that reflection, you are moving 12 units which direction? To the left or to the right? To the right. So to the left. Wait, maybe I'm doing something wrong. 3x is negative means it's a reflection about x. Whatever, I'm confused. Let's just find a number. That's much easier. Pick a number. Pick x equals 0. When x is 0, do you have a y value? What is negative 3 times 0? What is 0 plus 12? It's a real number, right? Positive. So when I say 0, y equals 12, our graph is here on this side. Now the question is, never mind. They're asking for the graph. They're asking for domain. Domain is this. So what is the domain? We know definitely it's negative, it's 4. But the left side of 4 or the right side of 4? Which side? Remember, when x is 0, how much is the y value we found? Y value exists somewhere here, right? So which side is the domain? The left side or the right side? The left side. So domain must be negative infinity to 4. Can you use 4 as our x value? Then I'm asking for the graph. So don't worry about the graph. They're asking for domain. What's the domain? So to find domain, we definitely need to know what is our vertical asymptote. How do you find the vertical asymptote? From the inside. And then you pick a point. Pick point from anyone. From the left side, from the right side. Whatever makes the inside negative, we cannot have the bigger domain. Let's say 55. Okay, suppose you're 55. 5 times negative 3 is negative 15. Negative 15 plus 12 is? So you will log negative. Does it exist? No. So can we have any graph here? No. So what is? Negative doesn't exist. Oh, for this one, negative. It's a reflection about y-axis going down, and we are shifting 12 units to the left. So it's going. Let me see the graph actually. It's all going down. Also, it's not going. Is it going down? Oh yeah, it's going down. I think it's going this way because it's a y-axis reflection. Just to see the graph. We don't need the graph here, but out of curiosity, let's see what is our graph. But did you understand how to find domain? Forget about the graph. Did you understand how to find the domain? Anyone who is confused? Because domain will be in the exam. How to find the domain in the next exam, not this in the exam. ln of what do we have? Oh, it's smaller ln, not bigger ln. 12 minus 3x. See, I was right. So when x is 0, our y is log 12. No, not log 12, right? Log 12 is 2.5. Probably. Let's see. Log 12. It's actually not log, it's ln. So 12 ln 2.5. See? 2.4 equals 2.5. No, it looks like 2.5. Between 2.4, 2.6, 2.5. So to find log, you start with the inside. To find domain, Inside the inside, because that inside definitely cannot be 0. That's our vertical asymptote. So see what makes the inside 0, and then you have to observe which side of the asymptote is it, our graph lies. Our graph will always be in one side of the asymptote. It can never cross the asymptote. So you have to find which side. Just pick a number from one side. If the inside is positive, that's the domain. If the inside becomes negative, that you cannot have. For example, for 5, we got something negative. That means 5 side is not in our domain. So the other side, the left side. Okay. Then we have find the domain in vertical asymptote. This one. Where is our vertical asymptote? X equals which number? -2. That means what is our domain? The left side or the right side? It's the normal graph. So 1, 2, you're moving 2 units, which direction, left or right? +2. So 1, 2, this is the graph. So which side is our domain? The right side. So what is the smallest number? -2. The largest number? Infinity. And they always have parentheses. Because this line is going on forever, so we have X forever. Now, how about the next one? Let's try drawing that. -5 means which direction? Right. And then +2. Up to. So this is our normal x-intercept. You're moving 1, 2, 3, 4, 5 up. 1, 2. So if I write 1 up, and this is your graph. So why is our vertical asymptote? X equals 5. So what is our domain? 5 to infinity. No. Base tells you how close it is.
It's like the base.
Javier. So this is 1, 2, 3, 4, 5. So this is the line we cannot cross. 5. So look at easy. What else we have? Da-da-da-da-da-da-da-da. Okay. The right one. We have a graph. Which one makes sense? The right one, the right side. And then you'll stop today. That's the last one, the right one. How do you see? What tells you?
Because
It's a log graph, so exponentials are out. So this one is left 2, and then 3 means up 3. So if this is a normal x-intercept, you are moving 1 left, 2 left, 3 left, 1 up, 2 up. So definitely here. First of all, this is right, wrong. This is also right, wrong. So, oh, sorry, yeah. 1 left, 2 left. Oh, yeah, I went wrong way. Right. So if you go 2 left, you still go 1 up, 2 up, 3 up here. Yeah.
on the wire.
Which one are you talking about?
She's asking.
The left side now.
Yeah.
This is just
This one, right?
Oh.
So it's a reflection about x-axis because it's in front. And then we have left 1 down 2. So this normal one, log of x, it reflects about x-axis. So it becomes this, because this is a reflection, x-axis. And at this point, you go 1 left here, and then 1 down, 2 down here. Bye-bye. Don't forget to bring a calculator tomorrow. A scientific calculator. I didn't make the exam, I went to make it today.
How many do you think, like 20? More than that?
Probably 20.
How long do you?
The final exam, 2 hours. Like final exam, 2 hours. Mhm. It's like with you.